Greetings fellow Earthlings and welcome to another episode where we blindly throw cheap parts at this car's hot start problem. This week it's the coolant temperature sensor's turn. The coolant temperature sensor is used by the car's engine computer to figure out the fuel mixture, the ignition angle, and when to turn on the cooling fan. As you may have seen in the intro, I did have a go at making a temperature sensor, but first let's install the real one.
We're going to start off with a 13mm on the airbox and loosening the 7mm on the other end. Then we can take off the mass airflow sensor and a clip that attaches it to the airbox, plus the oil filler neck can be unclipped. We can take the airbox out a little bit then. Then we can get to that second clip on the mass airflow sensor and remove the airbox completely. Now we can see our target. There it is. That's the coolant sensor. If we pinch that connector on both sides, we can pull it off the sensor itself. Here I'm using a chunky 22mm socket to loosen the coolant temperature sensor, but really there's too much coolant in the system just to whip it out and throw another one in there. What I'm doing then is using an H5 Allen wrench to open up the coolant console in the bottom there and drain out a bunch of coolant. It was easy to control the flow of that coolant by just opening and closing the cap on the coolant expansion tank. I took out about a gallon of coolant overall. That was where the flow sort of slowed down a bit. A lot of the coolant's going to be stuck in the radiators and the different pipes, of course. Now it was possible to loosen the coolant sensor without a tremendous flow of coolant. You just throw the new one in pretty easy. If there is a better way, please let me know. Maybe there is some proper way of doing it, but we didn't really lose much coolant at all. And then just plug in the connector again. It can only really go on one way. Clean everything up. Checked it out, no leaking or anything. Lovely. Then we're going to throw that coolant back in. This particular coolant has maybe 1,000 miles on it, so there's no problem in putting it back in. And then the airbox just kind of rolls back in. We can connect up the mass airflow sensor and a couple of clips for that cable as well. Then you're ready to clip in the oil filler neck. Then we use the 7mm to tighten the hose clip on the throttle body end of the airbox. And finally just tighten up that main 13mm airbox bolt. Then I just ran the engine for a little bit to see if we were coming up to temperature, and yeah, it all seemed to work just fine.
I mean it. Hit that subscribe button.
So did changing the coolant temperature sensor make any improvement at all? Well, I would say it's possibly slightly better at keeping a normal temperature, keeping around that 180 mark. But really it's pretty subtle, and I would say there's more to learn. One thing is I don't really think that was the problem on this car, first of all, but besides that, let's use my limited electronic skills and see if we can just test the resistance on the new one and the old one, and then have a go at making one as promised, hopefully.
Here's the new coolant sensor. It's easier to see on this that the 4 pins are numbered 1, 2, 3 and 4. Pins 1 and 4 send a signal to the DME, and pins 2 and 3 send a signal to the gauge in the dash. I don't know what a normal resistance reading is for one of these coolant temperature sensors. It is obvious though that the readings on the new temperature sensor are double that of the old temperature sensor, and I don't know if that is a normal variation or if that is a sign that that temperature sensor needed to be changed. If you think the aluminum rod that I'm using as a thermo resistor here looks a lot like Porsche Special Tool 9632 I made in episode 20, you'd be right. If you think it's no match for propane, you'd be right as well. Here I moved onto a brass rod, which seems to be functioning okay. It has a higher melting point. What wasn't good was my old, inconsistent multimeter. I replaced it with this new clamp style one, and I really didn't know what I was missing. it is much better. We're checking the temperature. A chilly 56 degrees here in California. Here's what I'm using to bring the heat. A typical hardware store self-lighting propane torch. And we're off. Immediately you can see that the resistance begins to increase as the temperature increases. The resistance of the brass rod increases because the energy input from the flame causes the molecules within the brass rod to jump around like a bunch of sugared up toddlers, and that makes them poor electrical conductors. And you can see once the heat is taken away, the resistance drops down again. And you could use that resistance output that the meter's reading to feed your computer in the car and do stuff with it.
Well, that was certainly a lot more fun than expected. It didn't fix the hot start issue on this car, unfortunately. The plot thickens on that one. You're going to have to tune in next week because that is all we have time for this week. Thank you very much for watching. Till next time.
Hold on, what's the dog doing? Oh yeah, subscribe now. Delta says thank you. Hey little buddy. Hop this way. Aww.